G'day guys, I'm going to go through the answers to yesterday's weekly notes assignment. So this is just a function, we don't actually know what it is. We could easily figure out what each piece is, so this is obviously just a straight line. We have a parabola, an inverted parabola that's moved across 3 to the left and up 5, so we could easily construct the actual function for this. But this is just a graphical representation of f of x. So f of x, this function, is made up of pieces that are defined differently at different intervals. So it's piecewise. So I want to know, if I put -6 into this function, what is my output? So my output when I put -6 in is 1. If you're following this line, you'd think it would be 2, but as soon as we get to -6, it's actually 1. So that's our first answer. Our second answer is what happens if we input, because this is our input and this is our output. I probably should have put that on there for the assignment, but if we put -3 in, what is my output? So if I put -3 in, I should have got 5. So 5 is the output for that problem there. And what happens when I put 2 in? Well, f of 2, that is undefined. I think I've meant -2 here. So that is undefined. There is no value associated with 2. There's just an empty gap there. Now we're getting into limits. So what is the limit of f of x as we approach -6? So here the actual value is 1, but the limit, as I get closer and closer to -6, I'm staying at 2, aren't I? So the answer there is 2. And it's not what happens at that point. I think that we'll never actually get there. It's just what do we think is going to happen as we get closer to that point from the left and the right, and we get closer to 2 because we're on a straight line. What happens when we, as we approach 2 at this function? So as we get closer and closer to 2 on this, we get closer and closer to 6. Again, I'm not interested in what's happening at the point itself. This is all about limits. It's all about what happens if we get infinitely close to that point. So the closer we get to 2 on the x-axis, the closer we're getting to 6 on the y. So that is our limit of the output. Okay, so where is the limit of the function and the value of the function different? It is here. So when x equals -6, the value is different from the limit, isn't it? It's like we've just taken that point and we've plucked it out and moved it down, but the limit would still be the same. So what values of x does a function not have a derivative? Well, we can't take the derivative at an inconsistency like this, at a discontinuity. So when x is -6, we can't take the derivative at a sharp point, okay, so at -4 and at -2. And again, we can't take the derivative at a discontinuity, so when x is 2. So when x is -6, -4, -2, and 2, we cannot get a derivative there. So for what values is the gradient 0? Well, the gradient is 0. So this is a little bit of different notation. I won't actually get into that in a video. I'll show you guys that sort of stuff in class, but gradient is 0 when x is less than -6, and when x is greater than -6 and less than -4. Okay, so we've got a gradient that is 0 along here. So I've had to split it up because I've got this interval, so from here back at 0, and from here to there at 0, and I haven't included those points because, like I said, there's no gradient there. It's undefined, and the gradient's undefined there, so it's strictly within those parameters. There's one other point, and that is when x is equal to 3. So -3. So that is because we have a maximum here. So if I was to put a tangent line on that, the tangent at that point would be 0. So there's 3 parts to that. When x is less than -6, when x is greater than -6 and less than -4, so in here, and when x is -3. And so for what values is the concavity negative? Well, it's concave down for all of these points here. So when x is greater than -4 and less than -2. So, and strictly between those 2 points. Again, you can't have concavity at a point that can't be derived. And there we have it. That is those are solutions to this week's assignment. Any questions? Put them down below.